Hello and welcome to the Daily Space. I am your host, Dr. Pamela Gay, and I am here to put science in your brain. Most of the time, the images we get back from spacecraft and telescopes are beautiful. Sometimes they're meh or boring. Occasionally, they are downright creepy. Early in this century, astronomers using the Chandra X-ray Observatory spotted a structure made of hot gas that looks like a creepy hand, one generated by your favorite special effects company. In 2009, the ghost hand was described as a 150 light-year spanning cloud of gas, illuminated by a rapidly spinning neutron star that is so small that it could briefly fit on Manhattan Island before its gravity destroyed the planet. Named B1509, this pulsar is only 1700 years old and would have formed in a supernova explosion while the Mayan civilization on Earth was at its peak and the Jin dynasty ruled in China. In addition to lighting a hand-shaped structure, the supernova also generated a shock wave that is expanding through space fast enough that we can see it change from year to year. In comparing images from 2004 and 2008 with data from 2017 and 2018, it is possible to see a ring of light the hand appears to be touching that is ever so slowly changing. That ring is where the shockwave is hitting a wall of otherwise invisible material and heating it up to be visible in X-rays. As the shock wave expands and moves through the wall, we see a larger ring. This is comparable to how a flashlight beam or headlights appear to be illuminating larger cones as they pass through a cloud of fog or dust. The science is super cool, or super hot if you want to be literal. The image, this is one that won't be going on my wall. From that creepy story, we now transition to something more bittersweet. One of Stephen Hawking's weirder theoretical discoveries about black holes has finally been observationally proven. 3 years ago, Hawking died at age 76, which is an age many of us can only hope to attain. Had he lived just a bit longer, however, this discovery might finally have allowed him to get the Nobel Prize so many of us hoped his theoretical work would one day earn him. Nobel Prizes are only given to living people who make discoveries of provable attributes of our universe, mathematics, medicine, chemistry, and other fields Nobel Prizes are given for. Theory alone doesn't get you one, and Hawking's theories exceeded our observational abilities until recently. This particular theory stated that while black holes can grow in area as they consume matter, effects like increasing spin can't shrink a black hole. This is sort of the inverse of the ice skater who spins faster when their arms are drawn in. Instead, you'd expect a black hole to get smaller as it spins faster. But it turns out that while you can form a smaller black hole by having it spin while forming, you can't shrink it by spinning it faster later. Physics of black holes is just weird, kind of uncomfortable to think about, and now testable thanks to gravitational wave science. By looking at pre- and post-merger data for a black hole merger, researchers were able to see in LIGO data the area of the final merged black hole exceeded the combined areas of the two original black holes. That Hawking figured this out without data to hint that this could be true, it shows just how creative his mind was. And this work is published in Physics Review Letters and was led by Maximiliano Eisley. One of the most delightful things about science is how wrong we sometimes get things. Take dinosaurs. I recognize dinosaurs aren't space, but Earth is a planet. An asteroid killed the dinosaurs, and dinosaurs were early life? So we're going to talk dinosaurs for a moment. Growing up, like most little kids, I was totally into dinosaurs. Now, to be fair, not much has changed other than I somehow forgot most dinosaur names that I knew when I was 6, which admittedly, most of those names have changed. So, anyways, dinosaurs. Once upon my childhood, we thought they were basically massive cold blooded reptiles, and like the iguanas that fall out of trees on cold Florida days, it was thought they just might not cope so well with the cold either. We were wrong. Dinosaurs were giant birds, not giant lizards, and as such seem to have been warm blooded. And like birds, they're capable of existing in all sorts of ecosystems that lizards dare not enter. New research published in Current Biology examines fossils from a region of Alaska that was near the North Pole when dinosaurs thrived and had weather not too different from snowy, cold Ottawa. These fossils demonstrate that at least 7 species of large and small dinosaurs who were likely living year-round in this Arctic region were breeding and raising their young there and surviving through the long, dark, cold winter of the extreme north. This work was led by Patrick Druckenmiller, who reports, "It wasn't that long ago that the idea of finding any dinosaurs in such extreme latitudes and environments was a surprise." Co-author Gregory Erickson goes on to say, Cold-blooded terrestrial vertebrates like amphibians, lizards, and crocodiles have yet to be found. Only warm-blooded birds and mammals and dinosaurs. I think that this is some of the most compelling evidence that dinosaurs were in fact warm-blooded. And folks, don't forget the feathers. These dinosaurs may have had feathers to help keep them warm. After the break, we'll be back to look at a different kind of sifting through the past, cosmic archaeology. Stay tuned. In a fascinating new paper in Monthly Notices of the Royal Astronomical Society, astronomers led by Nicholas LaPonte have done what I can only describe as an archaeological dig through the light of the most distant known galaxies to try and understand the ages of the stars in this old light. Let's break this down. Light takes time to travel. This means that when we look at galaxies that are 13 billion light years away, we are seeing light that was released from stars and hot gas when the universe was only 550 million years old. We know how to roughly judge the age of a galaxy or star cluster by looking at what distribution of stars is required to create the light we observe. To figure out when stars started to form, we can look at light from the oldest galaxies and then figure out how old their oldest stars are. When the universe was just 500 million years old, there were already stars that were 200 to 300 million years old. This means there were already stars forming when the universe was 250 to 350 million years old. This gives us a new and improved timeline for our universe. At time equals 0, there was a universe. People can argue that it was already there, but in a different form prior to t equals 0, and I'm not here to argue this detail. It is enough to say at t equals 0, there was a universe. By the end of the first 3 minutes, the energy had started to form matter, the matter by which I mean protons and electrons and such. That matter underwent simple nuclear reactions and created the initial mix of hydrogen, helium, and traces of lithium and beryllium nuclei that were the ingredients available for the first stars. For roughly 400,000 more years, the universe was too hot and dense for any structures to form, not even neutral atoms. And things just expanded with reverberating sound waves traveling through it, shaping the mix of energy and nuclei. Everything was opaque. And light could only travel the smallest of distance before being absorbed and re-emitted in a new direction. At least until one day, about 400,000 years after it all started. On that day, everything finally became cool enough and diffuse enough that the electrons and nuclei could finally form atoms. And with this simple change, light we now see as the cosmic microwave background was released to shine everywhere in every direction. And then, for a few million years, that not entirely smooth mix of material continued to expand and cool, all the time fighting against that expansion as areas with a bit more matter gravitationally pulled on their surroundings, pulling in material that would go on to collapse to form stars and galaxies. To go from a smooth distribution of material with place-to-place density differences of a fraction of a percent to having material dense enough to form stars. Well, that slow collapse against the expansion of the universe, it only took 250 to 350 million years. That may sound like a lot of time, but even here on the planet Earth, it really isn't. 300 million years ago, the oceans were teeming with the ammonite snails so many of us either have as jewelry or collect as fossils in Animal Crossing. Mammals, reptiles, amphibians, they all existed and lived in the shadow of the apex predator, the Dimetrodon. In the time it took life to get from Dimetrodon's ruling of the world to humans being humans, that is the same amount of time it took our universe, the entire universe, to go from zero to having stars. And that is your moment of cosmic wow. This next story takes us on a wild ride through history, and I want to give you a little context for what we're worried about. We have records all throughout literature, history, science that talk about books that we no longer have copies of, but we know existed in the Library of Alexandria. And when that amazing wonder of the world was lost, we lost forever probably some of the greatest writings and most important histories of early humanity. That isn't the only time we've lost amazing records. We've seen two different museums get lost to fire in Brazil. The Natural History Museum in London had what may be the bizarrest theft ever. Massive portions of their bird collection were stolen, one pocketful at a time, and turned into fishing flies in a lot of cases. That's data lost to biologists. All those losses are horrifying, but one of the losses that we can never recover from is the loss of our records of tree rings and ice that we use to study how our world has changed over time. Trees in particular. You can find a group of dead trees in the forest, take a cross-section of them, and find out by comparing those rings to the rings of surviving trees exactly when they died. And this is part of how we realize that a massive tsunami hit the American West Coast and killed off trees by inundating them with salt water in 1701. We can use these tree rings to track the cycles of the sun, to track the cycles of the seasons with drought and rain. And it's not just the dendrochronology that we worry about. We also have ice cores taken of glaciers that in some cases no longer exist, that preserve in them even older records than we can see and study with tree rings. And today, as we look at climate change, trying to figure out how to preserve these samples against, well, the weather is actually a problem. For 70 years, The tree ring samples that scientists rely on were largely stored under the stadium at the University of Arizona, which is a nice dry place. But you kind of want someplace better than under a stadium. To be fair, that's also where they build a lot of telescope mirrors. There have also been ice core storage facilities up in Denver that have been plagued by concerns about power outages tied to massive storms. So, what we really need is a place that we can keep all of these samples and preserve them into the future. And we also want a way to do this that will preserve them without having a massive carbon footprint. There's a certain irony in the fact that maintaining ice core samples at minus 36 Celsius actually produces a lot of carbon pollution that aids in the destruction of ice, preventing future cores from being able to be sampled. In trying to figure out how to overcome all these issues with preserving tree rings, preserving ice cores, one solution has been to take things to Antarctica. It's expensive, it's hard to work there, you can only get there certain months of the year. But unlike in the north, there is land to build on and ingenious ways to build new, essentially, warehouses for storing our scientific samples. They are literally, I kid you not, blowing up balloons that are 8 meters wide and 100 meters long. Sausage structures, they call them. They're letting them get buried in snow, letting that snow harden, and then removing the balloon structures so that they have new warehouses. This is part of a new project to make sure that we can hopefully keep some of our things permanently preserved. It's hoped that no matter how bad it gets, parts of Antarctica will continue to stay frozen. We'll continue to protect our ice cores and tree rings and allow future scientists to study where we've been while they survive wherever it is that we'll be going. All right. That's it for the death and destruction today. After the break, we're going to turn to something more joyful and look at a book that really is all you need to be able to figure out what good things you can go out and observe tonight. We'll be right back. Stay tuned. Hello and welcome back. I have with me my handy dandy 2021 Royal Astronomical Society of Canada Observer's Handbook. Now, I have to admit, I don't get a new one of these every single year. And I was really amused when I went to pick this up to realize that the 2001 version that I got back in graduate school, that is totally dog-eared and has been used to death, has a very similar cover photo. So I almost showed you 2001 today instead of 2021. Now, what I love about this book is it's filled with really cool illustrations that allow you to know, hey, November 19th, 2021, there's going to be a lunar eclipse, and here's where on the planet you need to be to see it, and here's what it's going to look like. And then it tells you the local circumstances for the solar eclipse that just took place. It has all these details taking you month by month through the sky, and I'm just like addicted to looking at this thing. But my favorite thing about all the different things in this book is it has tables of all the cool stuff you might want to look, and it lists out what season is ideal. This book, if you're not into eclipses, you don't need to buy a new one every single year. If you are into eclipses, meteor showers, all those sorts of things, get a new one every year. They're not that expensive, and they come from a nonprofit, and this book is awesome. And really, it's a must-have for anyone with a telescope. Go get one. You will not regret your choice. All right. We are not funded by the Royal Astronomical Society of Canada. They did not provide this as a review copy. This is an honest review. Take it and go explore the sky. This has been the Daily Space. We are here thanks to the generous contributions of people like you. If you liked what you saw, please consider supporting us. You can join us as a Patreon at patreon.com/CosmoQuestX or buy a ticket to CosmoQuesticon. Check out our website, cosmoquest.org, and find out more about our late July event that is a celebration of space and science and art and is themed 80s Space Party. I hope to see you there. Bye-bye.